Hello everyone, today in this video we'll be discussing the part 2 of module 1, and the previous part video I have already uploaded. You can find in the playlist given in the link is in the description box, and these notes can be downloaded. That link is also given in the description box. Okay, so before starting, if you like this video, hit the like button and don't forget to subscribe to my channel because your support helps me make more videos like this. So make sure you hit the like button and subscribe to my channel. So let's get started. In the part 2 we have mainly these three topics which are like very important ones, 10 mark questions. Okay, so from this topic only many questions can arise, and this topic as well. So we'll be discussing what are the questions and how do you need to appear, means write in the exam, what you need to write, and what are the important key concepts, what are the important algorithms and the diagrams. Okay, so if you study this much it should be sufficient for you. Okay, so let's get started. The first topic is state space search. Okay, what is state space search? We'll be going through from the basics to the advanced level. Okay, from the basics, what is a problem? Okay, means basically there is something to be solved, that is called as a problem. From there we will go to how to implement state space search to solve any problem using AI. We'll be reaching to that level. Okay, so let's get started. So I'll be opening the PDF. The below things are the application examples which we'll be discussing later. First we'll get done with the theory part. Okay, so the first question is, and wherever I have marked start, that is important. Actually, in this scanning of the PDF, I did not scan it properly, so some stars are missing from here. But in the description box, you can find the questions super important. Okay, so from the topic to many super important questions are there. Make sure you learn all of them and don't miss them. Okay, so let's get started. What is state space search? So if they ask you this question, you just not have to write like what is state space search. Okay, if you just write this much, what will happen is you will not get full marks. It's just one line answer. Okay, then what is the purpose of asking for 10 marks? One line answer. So how should we approach be is, what is state space search? What it is concerned with? It is concerned with solving a problem using a technique. Okay, repeat with me. It is concerned with solving a problem using a technique. So what is a problem? First you have to define that. Then how you will solve that problem? You need to do four things. You'll be writing this one, and then you'll be defining what is the state space search, brief introduction. Then you will be actually defining what it is. If you do this one, then only you will get full marks. Fine. So what is the problem? A problem can be caused using different reasons. Many reasons can cause a problem, right? And that problem can be solved in a number of different ways. That is called as a problem. Okay. A thing which is caused by many different reasons and can be solved using many different ways. If it is solvable, then it is called as a problem. First you have to define what is a problem. Then we have to build a system which can be used to define a problem, understand, analyze the problem, and then solve the problem by choosing the best solving technique. So first you will what? Define the problem, analyze the problem, isolate and represent knowledge. Isolate means what? If whatever the problem is, make it independent of the other factors and then see what is the actual root cause of it, because sometimes the independent factors don't matter at all. What matters is the root cause causing that problem. Fine, so we have to isolate that problem and represent knowledge. Represent knowledge means what is actually causing that problem. Knowledge of that should be represented, means that should be highlighted. When we do that, we'll get to know what is actually causing the problem. After that, we just have to solve the problem by using the best solving technique. Okay, what is a problem? What is problem solving? Searching for a goal state. So if suppose that what you have a problem, and let's take an example of football itself. Football is here and you have to kick it to go, make it go into the goal, right? So what is the problem solving here? The ball should be going here and searching for the goal state. This is the goal state. This is the closest example what I could come up at this moment. So whenever you get this question, keep in mind you are reaching the goal state. Finally you are in the initial state, you are reaching the goal state. Keep the example of football in mind. Fine. So the starting of the problem is what? Initial state. Initial state means where you are currently at, and the last point is what? The goal state or the final state. After 5 years, where do you see yourself? That is your goal state. Now where you are, that is what? Your initial state. Understood? That is called as searching for a goal state. Now state space search is a technique. Before state space search, we have to understand what is state space. State space, by the name itself you can understand, it is a space of states. There is a state 1, state 2, state 3, state 4, and this all is in a space, so it is called state space. It is a set of legal positions. What is legal positions? Where you can be currently at without violating any rules. where you can be currently at without violating any rules. Violating any rules means, suppose that let's take the same example, you are kicking the ball and it is going there. You have to kick the ball, right? That's first rule. You cannot be in a state like you can hold the ball in hand and run to the goal. You cannot do that, right? That's a violation of the rule. So that is a illegal state. What is the legal state? You are standing here and going to kick the ball. That is a legal state. Next state can be, you have kicked the ball and ball has started flying. Then the third state is, it is near the goal post, and the final one is, it is inside the goal post. Fine. So those are the different sets we'll be alterating after we perform one and finally reaching the goal state. Fine. These states are what it is called, legal states, and also this whole thing is called as state space. Now the next is, what is state space search, right? So state space search approach I'll be discussing more here, like the algorithm and all, but I'll be telling you one simple example. State space, you have all the states, and what is the best state you can choose to reach your goal faster. Suppose that if you choose this one, you will have to pass through two more states and reach the final goal. If you pass through this state, you will have to reach one and you have to reach the goal, and if you just use this one, you will directly reach goal. Now if I tell you, choose one state so that you can reach the goal the fastest way. Choose one state so that you can reach the goal the fastest way. Which one you will choose? Obviously you'll choose this one. This one, right? Because it is just one step away from the goal. If you choose this one, you will have to pass through two more steps. Which is the thing which you will be choosing so that you will reach the goal the fastest is called state space search, which is the best state I'm searching that. Fine. That is called as state space search. So basically, if they ask you about state space search, you have to write these four things. Moving on, we have the second question. What is the methodology of state space approach? Now we will be discussing in depth what is the method followed, what are the rules and the regulations followed when we solve any question using state space search. So basically, first you have to represent the problem in a structured form using different states. Whenever there is a problem, you have to divide that problem into smaller parts, take up each part and represent it using a structured form. When you represent it in using a structured form, it will be clearly visible what is actually the problem and what you have to do. Okay, then identify the initial and the goal state. What is the starting point and the ending point? Once you have done this one, then what you can do is determine the operator for changing the state. If you have to go to the here to here, it is not just one step, right? There are many steps in between. You have to do this, then go to this state, right? Like for example, if you want a job, you have to first prepare for apti, then coding, then technical interview, then HR interview, managerial, and so on. So you have to do all those steps, right? So what is the operator? Operator means at each step what is the task you need to perform so that you can move to the next state. At each step, what is the step you need to perform so that you can move to the next state is nothing but the operator. Then the next step is represent knowledge in commercial convenient form. Start from the initial state and search a path to the goal state. So that's there are two things left. Represent the knowledge in the convenient form. Start from the initial state and search a path to the goal state. Once you start, you can go to many paths here, but all those paths are not equally away from the goal. Some might be just one step away from the goal. So we have to choose the best one. So how to choose the best one? That is another technique called as heuristic technique, or also known as hint technique. Okay, so hint technique is not an official word I have given by myself because that helps remember the actual concept of that. So we'll discuss that in third part of the video. So for this one, just for this video, it's just about the state space search and the applications. Fine. So there's an example here. To build a program that could play chess, how do you play chess? There will be 8x8 boards. Some things will be here, some things will be here, and each thing has a set of rules which it can be applied upon. Like pawn can just move one or twice in the first turn, and then in the next turn just one. Knight can move I guess in the crossword, then I'm not sure actually how it moves, but there are many other rules for each of these which can be moved in different directions. Like some move just diagonally, and some move two side and then one forward. So those things are for different characters playing in the chess, right? So first what you have to do is specify the starting position, where you are starting from. That is the first thing you have to specify. Then what you have to specify is define the legal moves, means wherever you are starting from, where all you can go from this one, here, 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 or you can just directly jump to the other end of the board. What all you can do, that you have to specify. Then you have to specify what is the goal position. After me doing all these moves, what is the point if I don't define the goal positions? I'll be continuously infinitely doing this one without even losing or winning the game. There is no point in that, right? So what I have to do is I have to define what is the goal state. What state if I reach, I'll reach the goal. That you have to define. Fine. So that's what you have to write. What if they ask you about the methodology of the state space approach? First, you have to write what is the 5-step process. Very simple. Represent a problem. Identify the initial goal states and use the operator to change the state. After changing the state, reach the final position after searching for the best position. Then you have you can give an example as well, like the chess. Specify the position, starting and ending position, define legal moves and define the goal positions, and then try to win the game. Fine. Because in AI, it's not just about playing the game, it's about winning the game. To train the computer to win the game. Fine. Next, we have what is production system and its components. Very, very important question. What is production system? Production system means you will be defining a set of rules and the context. Okay, there are set of rules and the context in which it should be applied, and which rule should be applied when. These things, if you define in a system, that is called as production system. To solve any problem, you have a problem here. If you apply that problem to production system, hopefully you will get a solution for that. These things have the algorithms in that to solve this problem. These things have what? It have the algorithm to solve the problem. Okay, so first what you have to do is the entire procedure. So entire procedure for getting a solution for the AI problem can be viewed as production system. So whenever there is a problem, you have to solve that problem, right? So for solving the problem, what are the steps you will be following? All those steps come in what? Production system. All those steps come in what? Production system. Okay, so production system is a set of steps and the rules and the knowledge for using which we'll be solving any problem. Fine. Its main components are four. How many components are there? Four components. The first one is which one? Set of rules. There should be a set of rules which you should follow so that you can reach the goal. Then there should be knowledge base, means you should have any context using which you will be referring these rules and applying upon them. Control strategy means if you have 10 rules, which is the rule you will be selecting next? That's also a question. Just defining the rules does not suffice us, right? We should also tell the computer in which situation you have to choose which rule. Rule applier is that application of the choose rule. Fine. These four are the components. What are the four components? Set of rules, knowledge base, control strategy, and rule applier. Next, we have what are the algorithm for the production system. So basically, algorithm is also very simple. In this module, all the answers are same only. You'll be starting, you'll be doing some process, you'll be getting the result. Just remember these three keywords: start, process, end. That's all. See, here also it's the same thing. Represent the initial state. If the present state is the goal state, then obviously you have already in the goal state, you need not do anything further. Otherwise, choose any rules that satisfy the present state and apply it, and change the state to the next state. Then again repeat it, keep on doing it until you reach the goal state. See, it's the same thing here, but you will be getting the marks if you write it in a stepwise manner. So make sure you write it in an organized manner. Moving on to the next question, we have what are the classification of production system. If someone asks you what is the classification of production system, you have to say what? There are two classification of production system. Okay, what are the two? Forward and backward. Obviously forwards, then the opposite is backward only, right? So just have to remember one thing: forward, the other one is backward. Forward means what? Going front, going front, going front. That's all what you can remember. Moving from the initial state to the goal state, that's what is the forward. Backward means from the goal to the initial state. Now comes the wisdom part, why we are doing this one. Initial state to the goal state is followed when there are a large number of goal states. For example, this is the initial state, there are many goal states. Okay, so if you choose this goal state, it's not sure you'll come here, but if you obviously choose the initial state, you'll reach the all the goal states, and which is the correct one you will get to know. So in that case we'll be using forward propagation. Backward propagation means there are one goal state only, but many initial states are there. So what you will do, you'll start from here and see which is the best optimal position, and consequently, and at the end you will reach just one initial state. That is called as backward propagation. So what are the two production system classifications? Forward and backward. Forward, what you will do? Initial state to goal state. And backward, what you will do? Goal state to initial state. Fine. Moving on, we have the next question, which is what are the production system characteristics? Super important question. The production of the characteristics of production system. So there are mainly four things here. You have to just define four classes. Okay, characteristics is like, see, there is a production system. Okay, and it is not a general thing. It is having four categories. So each category will have some characteristics. So first step is what you have to define what is production system. See, any question they ask, you just not have to write what they ask. You have to write something else on the top. Middle you will write the answer. At the end you will write something else. Okay, so what is that something else? First you will write the production system definition. It is a good way to describe the operation that can be performed in a search for a solution of the problem. Just something about the production system you'll write first, then you will come to the main part, which is the characteristics. But before characteristics, you'll say that there are four classes of characteristics. So I have to first list down what are the four characteristics. So you first, what you'll be doing, you'll be listing down what are the four things here. After you have listed down, just briefly mention what it means. So I'll be giving you two hints to remember what does these terms means. Monotonic means what? Just single tone, right? Just speaking or doing something in the same way, right? That is monotonic. But I will be giving you another keyword here. You have to remember is monotonic means independent. If you remember this keyword, it will be very easy for you in the exam to write the answer. Remember, monotonic means what? Independent. Fine, in this context a monotonic means independent. I don't know how does that make sense, but you will get marks. That's what we want, right? It is a production system in which the application of a rule never prevents the later application of another rule. Okay, it is independent means whatever rule you choose, rule 1 or rule 2, whatever you choose, it will not prevent the another rule which could be chosen at the same time. Right, so these both are independent. If they are dependent, if you choose this one, this will not be able to choose this one. But they are independent. Independent means what? Monotonic. Whenever you hear the word monotonic, first thing that should come to your mind is independent. Fine, that's the first thing. Non-monotonic is dependent. Simple. 50% done. What are the characteristics? Rest 50% you have to remember a plus b is equal to b plus a. If you remember this one, rest 50% is also done. What is partially commutative? What is commutative first of all? Commutative means you can change the order, still you'll get the same answer. You'll change what? You'll change the order, still you will get same answer. That is called as commutative. So here what we have is the production system's rules. If a rule transforms state x into state y, then any permutation of those rules that is allowable also transforms state x into state y. So here the order, what? It does not matter. Order does not matter. Okay, keep this in mind. Order does not matter. That is the main key point here. That is partially commutative. The last one very simple. What is commutative? Both partially commutative as well as monotonic. Fine. So 100% is done here. Two things you have to remember. Monotonic means what? Independent. Commutative means what? It is a plus b is equal to b plus c. The order does not matter. Fine. After you have given these brief definitions, then you have to go for the example part. Here you have to explain in depth. See, it's 10-mark question. You just can't write one page and go. You'll not even get 4 marks. Fine. To explain it using examples as well. Okay, so you have to give 4 examples for 4 different kinds of problems, like partially commutative and monotonic. What is that? Partially commutative and non-monotonic. What is that? And the rest as well. Okay, so if you remember these keywords, it's very simple for you. So this theory part I'll not be explaining like by reading it. I'll be explaining just in my own words. You can go through the theory part later. Fine. So what is partially commutative and monotonic? The example is the theorem proving. In theorem proving, what we have, if we prove a theorem, we can prove it using many ways, right? There are n number of ways using which we can prove any theorem. So if we choose this way and then go and prove and see it is not working, then we can come back and choose this way as well. So choosing this way is not affecting the other way, other choices, right? We can again come back and choose this one. If this also doesn't work, we can again come back and choose this one. If this one also doesn't work, we can again come back and choose the last one, right? So that's what the monotonic is, right? It does not affect the choosing of the other options. And partially commutative means what? You can choose first this one or this one, then second this one, this one, this one, anything you can choose in any order. That doesn't matter, right? That's what it is, monotonic and partially commutative. The next one is non-monotonic, which is robot navigation. Non-monotonic means it is dependent. Means, for example, a robot navigation means what? Suppose that you have a maze here. Okay, in that maze here you have obstacles. Okay, so what robot will do? Robot is standing here. I told what the moves are not depend. The moves are dependent. Why I told that is, suppose that the robot can move in four directions: here, 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 here. Now, suppose that the robot moved here. Okay, then in this position he cannot move here also, here also, here also. He should just go back, right? So that is a dependent move. Because of the move made here, he is not able to move in any other directions, and he should come back and move here. But whereas it's not the same in the theorem. Theorem, what happens if this doesn't work? Again, you can start from here itself. But here he should find out the way to come back here, right? So it is dependent. He made this move, so he came in a position here, so he is supposed to move back here. The move is dependent here. That is what is called non-monotonic, and it's partially commutative. Why? Because first you can move this one or you can move this one. The order does not matter, but it is dependent. Okay, that is what is called non-monotonic and partially commutative. Non-partially commutative and monotonic. Non-partially commutative means what? The order matters, but it is independent. The order matters, but it is independent. So it looks contradictory. Let me give you an example. Chemical synthesis means what? You have a formula. If you do A plus B, you will get C. Okay, so here the order matters. First you have to take A, then only put in B. Otherwise, what if you take B and put in A? It might blast also, right? Something is there with sulfuric acid, right? If you put sulfuric acid in water, then it is fine. But if you put water in sulfuric acid, it might blast, right? That's what's happening in the same way. The chemical synthesis, you have to follow the steps. Order should be there, but it is independent. Means first what chemical you take, that does not affect the taking of another chemical at a later time. You can take this one also. No one cares which one you take, right? But the order should be correct. If you take this one, it has a separate order, that should be followed. If you take this one, it has a separate order, that should be followed. Fine. Next we have non-partially commutative and non-monotonic. So bridge is a game. I'm also not sure what it is, but it is non-monotonic as well as non-partially commutative. What it means in other terms is the order should be followed as well as it cannot be independent. It is dependent. It is dependent as well as order should be followed. Fine, then only you'll get the correct answer. So it's basically in any complex situations and all, or the complex problems when you solve, the order matters a lot, and everything is not independent. They are closely related to each other, the steps. So it should be very carefully made. Means the we should proceed with the steps very carefully. Okay, so that was an important question. So what all you need to write? First write about the production system here, then write the four things in brief, then using an example you have to make this table, explain what all these things in your own words. Again, the same things are here. If you want the key points, you can go through this. Okay. Next, we have list the requirements of good control strategies. A very important, super important question. What are the good control strategies? Before moving on to the before moving on to good control strategy, you have to first define what is a control strategy. Control strategy means that only what I told you. If you have 10 rules here, which is the rule you are going to take at this moment of time? Okay, which is the rule which you are going to select at this moment of time so that you can get the best solution. That is what is called the control strategy. It specifies the order in which the rules will be compared to the database and the way of resolving conflicts that arise when several rules match at once. If several rules are possible, which is the rule which you are taking so that you can get the solution? That is what is called control strategy. What is the requirement for good control strategy? There are how many requirements? Two requirements are there. The first requirement is that it causes a motion. Causes a motion means if you are in a state 1, suppose that you are standing here and your home is here. Okay, this is your home. Now the first requirement is it should cause a motion. Cause a motion means whatever step you take, it should make you near to the goal, right? Whatever step you take, it should make near to the goal. That is what is called motion. In fact, just motion means either forward or backward, anywhere, but you should not stand there itself. If you stand there itself, you will never reach the goal. But if you move backward or forward or something movement, if you do, there is a chance that you might reach the goal. That's the first requirement. Fine. So it should cause a motion. Second is that it should be systematic. What does systematic means? Suppose you're standing here. Let's take the same example. Your home is here. Now what you do, you went to a party, you came, you are drunk. What you will do, you'll move one step forward, then again move one step backward, one step forward, one step backward, like that you keep on, and you'll be staying there itself till the morning. Fine. So that is not should be done. It should be systematic. Means whatever move you are making in the long run, it should be actually feasible. Just making moves doesn't matter. To make a feasible and like actual move should be there, which can make you reach the goal. Again, doing one step and redoing the step doesn't make you reach the goal, right? That's the requirements for good control strategies. Okay. Next one is what are the issues in the design of search programs? Okay, so first you have to define what is a search program, and then you have to define the issues. Since we can all define what is a search program, a program for searching something, I just have discussed the issues in the design of search programs. The main issues is the checking of duplicate node. So if there are duplicates node getting generated, or if the redundant data is getting generated, that has to be handled and that has to be removed and resolved, right? So that is the first issue. Second is that you have to only choose those strategies which are likely to reach the goal. You don't have to choose the strategies which can lead you to somewhere that is not sure that you might reach the goal or not. So you have to always choose the best possible choice which you can choose. Fine. So few more issues are that the tree can be searched forward from the initial node to the goal state, or backward from the goal state to the initial state. There are two possibilities, and every time these two possibilities might not work. The next one is to select applicable rules. Okay, there's also an issue, which is the applicable rule that we have to select. For that, first we have to tell the computer what is applicable rule and what is not applicable rule in a given context. Okay. The third one is a representation of each node in the search process. First, you have to represent each node, like whatever the state you are in, that should be representable. If it is not representable, you cannot solve it, right? So first is the representation, means using any data structure. That are the three issues in the design of search process. Okay. So coming to the water jug problem, a very much repeated problem. Out of five previous papers, four papers have asked this one. It's also there in the model question paper. Whatever you missed, don't miss this one. Very, very important question. So listen carefully what the question is and how do you need to solve. What are the things you need to write in answer to get full marks. Those all things I'll be discussing in depth. So make sure you listen till the end. Fine. So, what is water jug problem? You are given with two jugs. How many jugs are there? Two jugs are there. A 4 gallon and a 3 gallon one. Okay, two jugs are there. One big one is 4 gallon one, and the small one is how much? 3 gallon. Okay, which you can use to fill the jug, means in that we can fill the water, and the ground on which the water may be poured, means you can fill the jug as well as empty the jug. Neither jug has measuring markings on it, means we just know that if we fill the jug till the end it is 4 gallon, or if it is like the smaller jug, if we fill till the end we know it is 3 gallon. That's all we know. We cannot tell what is the half, what is this one, although by common sense we can tell this one, but that's not allowed in the question. Fine, in the question we cannot do that. How can you get exactly 2 gallons of water in the 4 gallon jug? That's the main question here. How can you get 2 gallons of water? The main thing is how can you get 2 gallons of water in the 4 gallon jug? Since the markings are not available, it's not that simple. We cannot just pour the water till we feel like yeah it's half. No, that is totally invalid. Okay, write down the production rules. See the question what they have asked. Write down the production rules for the above problem. First you have to define what are the production rules, then we have to write down any one solution to the above problem. See, production rules can be one. There are rules defined here, but you can have n number of solutions. It is possible that there might be no solution, there might be just one solution, there might be multiple solutions. Okay, so any one solution you have to write. For this problem there is a solution. They have asked one solution, so you can write any valid solution. Two things: production rule and solution. So first let's go through the theory part. What are the things present here? Then I'll be explaining you using the visual like drawings and all how it works. Okay, so for this solution, first you have to define what is state space of this problem. State space means what is the legal positions. Legal position means if you have two jugs here, what are the legal positions for the two jugs? Having 0 liter here and 1 liter here, having 2 liter here and 3 liter here, having 4 liter here and 1 liter here. All those combinations are the legal states. Okay, so first you have to write this one. For every problem what they ask, there are totally four problems here: water jug problem, Tower of Hanoi, traveling salesman, and missionaries and the cannibals, as well as monkey and the bananas. Okay, totally five or six problems problems are there. So you have to first write this one for each of the problem. Even if I have not written the next problems, you are supposed to write this in the exam if you want full marks. The state space for the problem can be described as a set of states. There are set of states. Fine. There are what? Set of states, and each state represents the number of gallons in each state. Okay, so if this is one state, I call it state one. In state one, what will have? Two things will be there. How much water is there in the 4-gallon jug and how much water is there in the 3-gallon jug. This constitutes my first state. Like that, second state will have a differing number of gallons in each cup. Fine. So after you have written what is state space for the given question, then you have to write how the game starts. It starts from the initial state and reaches the final state. So what is the state first of all? State will be defined by two parameters here. How many parameters? Two parameters will be there in the state. X is the number of liter in the 4-liter jug. Y is the number of liter in the 3-liter jug. These two things you have to define. At each point of time, I can ask you how much water is there in the 4-liter jug, how much water is there in the 3-liter jug. You have to see your state and tell me the answer. Okay. So when I will be doing the explaining through visuals, you have to tell me the answers. Fine. So the start state will be 0 0, means initially it will be empty, right? You will just be given with the jug, there will be no water in it. Fine, it will be empty, so the start state will be what? 0 0. What is your end state? End state means they have asked us to calculate the means you have to show the steps by using which we can reach the final state. Now what is the final state? How that can be represented using state space? The final state says that in the fourth in the jug with the 4-gallon there should be 2 liter of water. So here in the X it should be 2 liter of water, and Y can be anything, I don't care. They have not asked about Y. It can be empty, it can be full, partial, whatever it wants. I don't care about Y. I just care about this one. It should have 2 liter. That's all. I'm satisfied. So goal state will be 2 comma n. N will be anything in 3-liter jug and 2 will be there in the 4. If this is satisfied, I have reached the goal state. Fine. Now to reach the start state till the goal state, there will be few steps, and in each step you have to keep in mind some rules. That rules we have to define here. Okay, so these are the rules which are defined. I'll come back to this after I'll be explaining you using the drawings how it works. Then this will make more sense for you, and after that we'll be using the one of the solutions. So there are many solutions for this problem. One of the solutions I've given here. So these two things, which is the production rules as well as the solution part, I'll be discussing after I give you the visualization of how this works. So let's go to the sketch pad. Okay, so this is the sketchpad here, and this is the problem given to us. There is a water jug problem. So 4-liter jug is here and 3-liter jug is here, and this is the tap. Okay, so water is coming from here. We can fill either 3-liter one and 4-liter one. Okay, so final state, what we have to have is 2-liter one here. So what you can do is you can fill 3-liter here, you can pour it into this one, and how much water is there, you can either empty it or you can pour in this one. First you can fill this one, then pour into this one. Many things you can do, right? Many things you can do. So if you want to solve it yourself, you can pause the video, think about it, and come back to the video. And if you want to watch, you can continue watching. Fine. So let's continue. So first step, what you have to do is first you have to fill 3-liter water full. Okay, so how much water is there? Every time you have to say me the state. Okay, so what is the state here? So I'll be writing the state here. It is 0 comma 3. Okay, so because 0 liter is here and 3-liter is here. Fine. So that's the first state, 0 comma 3. After you have filled this one, then next step what you have to do is whatever water was present here, that you will be pouring here. So what is the state in this case? Tell me. 3 comma 0. Okay, after you have poured this one, means the 3-liter jug's water in the 4-liter jug, then what you are supposed to do is again fill the 3-liter water jug. Okay, now what is the state here? 3 comma 3. After you have done this one, then what you do, you have to pour this water. Okay, 3-liter water you have to pour in this jug until it becomes full. Now how much it is there? 3 is there. To become full, how much it needs more? Plus 1. So 1 liter will be transferred from here till here. Okay, so what will happen in the next state? This will become 4 and this will become 2. Right, this will become 2. Now see, you have reached the final state here, but it's just a different jug. 4-liter jug should have 2 liters. So what you will do, you'll just simply pour it out. Okay, so what is the state here? It is 4 comma 2, and you'll pour it out means you'll empty it, you'll throw it into the ground, and then what you'll do, this is 2 liter, you'll just transfer it. Okay, so what is the previous state? It is 0 comma 2. What is this state? It is 2 comma 0. So 2 comma 0 is similar to 2 comma n, isn't it? And I don't care what is n, I just care 2 should be here, and this is here. I have reached my final state. So I hope so you got the solution to this one. Again repeating, you have a 4 liter jug here and 3 liter jug here and water here. First you will fill the 3 liter water and then pour it into the 4 liter water. Again fill the 3 liter water and pour into the 4 liter water until it gets full. Now the remaining one is just 2 here. So what you will do, you will empty the 4 liter jug and pour the 2 liter into the 4 liter jug. Okay, so this is the explanation for this one. Now let's go to the theory part and see what you are supposed to write in the exam. So the production rules first you have to write. It's compulsory. If you don't write production rules, you just skip that answer and go. No need, you will not get any marks. Fine. So what are the production rules? There are totally 12 production rules. So how to remember this one, that also I'll tell you now. See, the first is like in which state you are present, what state you will go, and what is its explanation. Explanation is just optional. These two things you have to compulsory write. Starting state, if this state is present, then which state you can go. Okay, so see here, it is written x comma y and the condition given is x is less than 4. If x is less than 4, then what you can do is you have to fill the 4 liter jug full, means it should be full of water. So x is less than 4 can be the state 0 comma 0 when it is empty. So if it is empty, either you can fill the 4 liter jug or you can fill the 3 liter jug as well if y is less than 3. If this rule is there, you can go here as well. Like if it is 0 0, you can fill 4 or you can fill 3. Both are the valid moves you can make. Okay. The third one is if x is greater than 0 here, what you can do is, see, there is 4 here and there is 3 here. X is greater than 0 means some water is present here. At this case, what you can do is pour out some of the water out of the 4 gallon jug. Means you can pour some of the water, but you'll be not sure how much water is left here because you are just pouring out, right? We are not sure, there is no marking how much water is getting poured out, but it is a possible move. Just pour out some water, that also you can do. Okay, same goes for y also. You can pour out some water out of y. So if it is x comma y, the final state will be x comma y minus d. So d water is poured out of the y, so the final state is x comma y minus d. The next state is if x comma y is there, you can empty the 4 gallon, like pour out a whole water what is present here. Whatever is present here in the 4 liter jug, just pour out it whole, so it will be 0 comma y. Same goes for the y as well, x comma 0, pour out all the water in the 3 liter jug. After that, see, this one is important one. See, till here it's the basic rules. From here it comes the main rules. Okay, so main rules means x comma y is present and the condition is x plus y is less than or equal to 4. For example, let's take x has 3 liters and y has 1 liter. So x plus y is greater than or equal to 4. Yeah, it's true. And y is greater than 0. That's also true. What we can do is we can make it 4. Means whatever is present here, pour it here. Okay, whatever is present here, pour it here. And this one will be y minus 4 minus x. What is 4 minus x? 4 minus x means 4 minus 3. Okay, 3 was here. 4, 4 is total. 4 is total and 3 is here. What is remaining here? That value is 4 minus x. Okay, this value is only 4 minus x. This value you have to subtract from y. Y means what it initially had. You have to subtract this value from y. Why? Because by this one I'm pouring how much? I'm pouring just this much to make it full. By this one I'm just pouring this much to make it full. So this much should be subtracted from y, right? This much should be subtracted from y. That's all that I'm doing. Y minus 4 minus x. So that will be my final state. Pour the water from the 3 gallon jug into the 4 gallon jug until the 4 gallon jug is full. Keep pouring from the 3 liter until 4 liter becomes full. The reverse can also be done. Pour from 4 liter jug to 3 liter jug until 3 is full. Okay. Then we have pour all water from the 3 gallon jug to the 4 gallon jug. Whatever is there from the 3 gallon jug, pour it into 4 gallon. Whatever is there in the 4 gallon, pour it into the 3 gallon. And if it is like 0 comma 2, pour from 2 to 0. If it is 2 comma y, just through the water which is in the 4 liter jug. Means we have reached the final state. We need not need any water more. We can just empty the gallon. Okay, those are the rules you have to write. Just go through it once, you can get to know. Okay, just remember this one, very very important. It's compulsory for you to write. Then how do you find the solution for it? Very simple. You just have to write how much is the state here, state x comma y. What is the rule getting applied? 0 comma 0, the first rule is getting applied is rule number 2, which says x comma y goes to x comma 3. X comma 3 means first you will pour 3-liter water in the jug. Okay, 3-liter water in the 3-liter jug, so the state will be 0 comma 3. Okay, those same states which I was telling, like tell me what is the state at each step, right? Those same steps you'll have to write here. That's only I told you, tell me. Okay. Now it will be easy for you. Then if it is 0 comma 3, the ninth rule will be followed, which is x comma y is equal to x plus y comma 0. Whatever is in the 3-liter jug, pour it into the 4-liter jug. That is the rule number 9. After I have done this one, then similarly you will do the same thing again, which is 0 here, fill it to 3. Again, 7th rule, fill whatever is in the 3, fill whatever is here until this becomes full. Remember rule number 7. What, see, this is the rule number 7. I told you, right? Pour water from 3-gallon jug into the 4-gallon jug until 4-gallon jug is full. So you'll be pouring the water from this one until it becomes full here. Okay, so how much should be subtracted? What is the space present here? That should be subtracted from what is the capacity of 3-liter jug. Okay, that's what we are doing here. 3 was there until it becomes full. It just needs one more, so I'll subtract 1 from here and put here, so it will be 2 comma 4. After that I have reached the state where I have got 2 here, so I'll throw this water out. After I have emptied this water, it will be 0 comma 2. I'll transfer 2 here and it will be 2 comma 0. Fine, so this is the 3-step process. What you have to write: the first step, you have to write the specification, like what is state space, initial and final state, what is the states present here, how do you represent it, and what are the production rules, the second step, and the third step is the solution. Okay, so this is all what you have to write. And any problem in AI, what they ask. Fine, let's move on. The next question is the chess problem using AI. Okay, very very important question, but it's not asked in the previous year papers. But if you understand this problem, the questions which are asked in the previous year paper will be very simple for you. So that's why it is an important question. What is a chess problem and how do you use solve it using AI? So first you have to define what is the problem. Playing chess can be defined as a problem solving moving around a state space where each state represents a legal position in the chessboard. See, what is the only thing is wherever you have placed your characters, that should be in legal position. That's the only problem in chess. And you have to start from the initial state, which is a legal opening chess position. Goal state means opponent does not have any illegal move or king is under attack. That is the goal state. In between them, you'll have production rules. So some production rules are given here. So go through it briefly. It's not like you have to understand the chess working for this solution. Basically, all you have to do is wherever the character is presented, which are the valid moves you can make. You can write this in your own words. It's not compulsory that you have to write this one only. Just make sure that the meaning does not change. And what are the different rules for different characters? Few rules are given here, the rest you can write. That's what is the chess problem. You have to define starting and ending positions. After that you have to define what are the rules present here. And solution is not possible because chess is a very big game. You cannot write the solution so easily. It will be like 2 or 3 pages because many moves are possible, and also it's not even asked in exams. Okay, next we have 8 puzzle problem using AI. 8 puzzle problem means what? This is the 8 puzzle problem. Here you will be having the initial state of these things here, and the final state should look like this. By sliding the tiles here and there, you can make the changes. Finally it should look like this. Okay, so how do you do this? Is first define the state space. Each state space is a set of states where each state is a position of the tiles in the tray. After you have defined this one, what is the valid moves you can make? Wherever there is an empty space, either you can exchange this one or this one or this one, right? So that's what you are checking the positions in the north, south, east and west direction, and making the changes. That's what the production rule is. Tile in the square 1 1 and empty square 2 1, so exchange 1 1 to 2 1, right? That's all you'll be doing for each of those possible moves. Next, we have the super important question, which is traveling salesman problem using AI. So, what is traveling salesman problem? This is the fourth semester we had studied. If you have 4 cities here or any n number of cities, and traveling from each city to another city will cost some money, like 5, 25, 10, 15. Okay, so now what you have to do is you have to reach from this city to this city. Okay, so what is the best move which you can make? What is the best move for which you can make? Let's take it as 2. What is the best move you can make from reaching from A to B? Okay, so what you will do, you will reach here and reach here, or you can reach directly here. But if you go and reach here like this, in that case you will be costing 7. 5 plus 2, see, 5 plus 2. If you go directly, it will cost you 10, which is more cheaper, this one. So you obviously choose this one. But it's not just about reaching the final city, you have to travel all the cities. So I didn't draw properly. You have to travel all the cities and reach the final state. Okay, That's what the traveling salesman problem is. The problem is given here, you can go through it. It also should visit every city exactly once. Okay, then what is the solution? The state space is given. It is just showing the path, from which path you can go all those positions. Like one path is called one state, another path if you give, and that is called another state. So this constitutes one state, this constitutes another state. Okay, initial state is the starting city and final state is the ending city. Production rules are also very simple. If you have visited the city I and you have not visited the city J, traverse from city I to J. That's all. Traverse means travel. If you have visited Mumbai, you have not visited Delhi, just traverse from Mumbai to Delhi, right? If you have visited Mumbai and Delhi, you have not visited Kolkata, you can just visit from Delhi to Kolkata. That's what traverse city J to city K, Delhi to Kolkata. Like that, the different rules are there. Whatever city you have visited and not visited, just traverse from that to that. And if you have visited all the cities and not visited is null, means all the cities you have visited, move back from the final city to the initial city. That's all. K to I. Okay, those are the four rules you have to write. Next, moving on to the super important question, which is Tower of Hanoi. Tower of Hanoi, I'll directly explain using the visual representation itself. So problem is also same. You can go through it, as well as the initial state, empty state, production rules, push and pop is there. So I'll just give brief information about this one after coming back from the visual representation. Okay. So let's move to the visual representation. Down. Okay, so this is the Tower of Hanoi problem. So in Tower of Hanoi problem, what is the rule? See, there can be n number of disks. Okay, this is known as disk. Okay, there can be n number of disks. So here how many disks are there? 3 disks are there, and it should be only arranged in the order where the bigger disk will be there, then the smaller one, then the smaller one, and so on. What is illegal is you cannot put like this. Okay, this is illegal. Why? Because there is a bigger disk on top of the smaller disk, right? It's not possible. So this you have to avoid. So what we can do, we have to make this whole thing here. That is the final state. This is the final state, this is the initial state. Initial state, it is on the T1, final state it is on the T2. T3 can be used as a temporary tower. Okay, so and another rule is that we cannot move two things at a time. We can move just one thing at a time. Okay, like one thing we can move here, then in the next iteration I can move this one here, and so on. And the last rule is that we cannot take out this one until everything on top of this is taken out. Means if I have to take this one, what I have to change this one here, and I have to change this one here, and then I can change this one. Okay, then only I can move this one. So let's see optimal solution for this one, how we can solve. Okay, so this also we are studying in the third semester. Again, I will tell you, I will revise what are the concepts here. So see here, first what you do, make this into T2, put it on T2, put it on T3, and then take this, put it on here, and then change this one, and then change this one here, change this one on top of this one, and change this one on top of this one. So if you want to rewind the video, you can watch again. So this is how you transfer the tower from this position to this position. Fine, that's what the working of Tower of Hanoi. Let's go to the theory part quickly, so that you can know what you have to write in exam. Define the problem. It is a state space. For the problem can be described as state representing position of the disk. This is the keyword, position of the disk on each pole. The position can be treated as stack. The length of the stack will be equal to the maximum number of disks the post can handle. So what will be the stack? Stack means last in first out. In the disk also it is same. 3 disks are there. Last in is the first to be output, right? And it will be the maximum number of disks will be like what the pole can handle. If there are 3 disks at one time, maximum 3 only can be there, because there is no other disk. How will a 4 disk come? Very simple common sense, right? Initial state will be, this will be full and this will be empty, T2 and T3. Goal state will be in T2 it should be full, this will be empty. Production rules, either you can pop X or push X. Like pop X means remove the element from the, one of the towers. Push means remove the element X and put it in the Y. So production rules are very simple. Top of T1 is less than top of T2, means there are two towers here. So um, let's take it as this one, and this is the smallest one. Now this is T1, this is T2. Now if top of T1 is less than top of T2, top of T1 means this one, top of T2 means this one. Is this less than this in size? No. Is T2 less than T1? Yes, T2 is less than T1. So what you can do, push pop T2 into T1. Pop T2 will take out this one where you have to push in T1. So it will push here, it will come here. Like that, this is one of the rule defined. So basically we need not do all the rules which match, but we have to select specifically which actually matters. That rule only we have to do. Like that, it is defined for the other towers as well. Whichever is less, pop that. Very simple to remember. T1 is less than T3, pop T1, put in T3. Whatever is less than which, pop that and put in that. Okay, then if it is empty, then just push it. Like if T1 is empty, pop T2 and put in T1. If T1 is empty, you can pop T3 as well and put in T1. See, if T1 is empty here and T2 is here and T3 is here. Now there is two disks here. Now in T1 there are two possibilities. Either I can pop this one and put here, or you can pop this one and put here. Right, both the possibilities are valid moves. So both of the rules are defined. We need not perform both of these rules. You have to select which is the most specific rule which leads us to near to the goal position that you have to apply. How to choose that one, that is in the third part of the video, heuristic methods. Okay, in that we'll be learning how to choose that one. So one of the solutions is given here, that same thing I have explained. So if you don't understand this one what it is, see here, T1, T2, T3. Okay, so here one big one is there, it's smaller than that. T1 goes to T2 means this one will go here. Okay, so this one, just imagine, okay, the same thing what I've explained, that only T1 goes to T2 means this will come here. Okay, just keep in your mind, this is vanished from here, it came here. T1 goes to T3 means this one came here. Okay, next T2 goes to T3, T2 goes to this one will come here. Okay, and this is empty now. T1 goes to T2, T1 goes to T2 means T1 has this one, it goes to T2 means it will be a big block here. And T3 goes to T1, T3 goes to T1 means the smaller one comes here, this is empty, the smaller one, so in T1 only smaller one will be there. T3 goes to T2, so T3 has the medium one will go here on top of big one, so this is big one, then medium one, and then T1 goes to T2, T1 is small one, it goes to T2, so here, so BMS, right, big medium small. So it is in this form, that only we wanted, big medium small form from T1 to T2. So this is how the solution works. And if you did not understand this one, you can rewind the video, you can watch again the visualization, in that you can easily understand this one. Okay, that's all about the tower of Hanoi problem. Same things, first define what is the problem, define what is the initial goal state, production rules, and then one of the solution. Moving on, we have the monkey and the banana problem. I'll be explaining this using the visualization. So see, very simple one here. There is a monkey, okay, he's very hungry, he has not eaten from many days. Okay, no one gave him food and he did not eat also. Okay, so what he is doing is he found a room in which, in the ceiling of the room, right, ceiling means if you look at the top there is ceiling, right, in that there are many bananas there. Okay, but monkey is not that tall, he can just raise his hand and take the banana, so he has to take help of other things. Now other things means the chair and the stick and all. So what he does is he have to place himself in the chair and take the stick such that he can reach banana, that all things should be satisfied. If he miss any of those things, it will not be satisfied. For example, monkey, he took the chair, he took the stick and he placed here, but the banana was not here. He should have placed the chair here. What if he placed the chair here also, but stick he is pointing here, like an idiot, he's pointing the stick here, then also he'll not get the banana, right? If he needs the banana, all these things should be satisfied. That's what is called the monkey and the banana problem. Okay, so the same description is given here, you can go through it. The solution is also given here, so it will be a 5 tuple representation. MCS F1 F2. M is the position of monkey, position of chair, S is the position of stick, F1 F2 is 0 or 1, either monkey is on the chair or not, F2 is monkey is holding the stick or not. Okay, if he just climbs on the chair and everything he does, but he does not pick stick only, will he get the banana? No, right? That's what it is. Initial state will be what, MCS and 00 means all these will be in different positions, and everything will, he'll not be holding stick, nor he'll be standing on chair. Next is goal state. Goal state means all these three should be in the same position. If the banana is here, all these three, monkey should be here and chair should be here, stick should be here. These all what, same positions. So same positions are represented by same letter. 1 means he's holding the stick as well as he's on the chair. Okay, so those things should be satisfied for the getting of final answer. Okay, then we have the production rules defined. It's very simple rules. MCS 00, ACS 00. A is the arbitrary positions, means where he has to actually reach. Okay, means there is the banana, you can reach that space. MCS 00, if it is there, you can either go for CCS 00, means M went to C means where is the chair? He went to there and he is beside the chair. He has not standed on the chair. Okay, so monkey is just moved to the chair position. Next one is monkey moved bring the chair to the state position means he went to the chair position. He brought the chair to the stick position. Okay, so stick, monkey, and chair are in the same position. Then again arbitrary positions, push the chair towards the arbitrary position A because in arbitrary position above arbitrary position there is banana. So move the chair to the arbitrary position and move the stick to the arbitrary position, and then move both chair and stick to the arbitrary position, and then hold the stick as well as stand on the chair. That will give us the final solution. This is one of the, this is only one problem. This is only one solution to this answer, where you have if there is one banana, there should be the three positions should be same. You should hold the stick as well as stand on the chair. That's what you have to explain here, and the solution is also given here. The steps are given, like first monkey goes and brings the chair, then he holds the stick, and then he stands on the chair, then he waves the stick to the banana, and if the position is correct, all these three things are same and it's 1-1, you'll get the banana. Okay, so that was about the monkey and banana problem. Moving on to the last one, we have explain the missionaries and cannibals problem. Okay, so in this problem I'll be explaining you using the visualization. So listen carefully what happens here. So see here in missionaries and cannibals problem, there are two people. Okay, missionaries and the cannibals. So missionaries are represented as the black, cannibals are represented as the red. Okay, so what we have to do is we have to cross the river. There is a river here. Okay, in between there is a river. Now we have to cross this river and bring all the people into the next part of the river. So for that, what we will be doing is there are some rules defined here. What is the rules? The rules is that at any point of time, at any point of time, there should be no more cannibals than the missionaries. For example, what I mean to say is, see here, if it is like okay, this position is invalid. Why? Because there are more number of cannibals and less number of missionaries. This should not be done. Okay, just assume that there will be a fight between cannibals and missionaries, and that should not happen. So there should be equal number, or cannibals should be less number. Okay, if cannibals is less number, obviously they cannot find with the missionaries who are in the greater number. Okay, so that's the only rule. At any point of time, missionaries should not be less than the cannibals. Missionaries should not be less than the cannibals. And at one point of time, only two people can sit in a boat, either two missionaries or two cannibals, or one cannibal and one missionary. Okay, so you have to cross the river. So one of the solution for this one is, like, take see, two cannibals will be sitting here. Okay, and they cross the river, and one of the cannibals will be moving out of this one. Okay, and they'll come back here, and after that one of the missionary will be coming and sitting here. Okay, and they'll be again coming here, and one missionary will be moving here, and again the cannibal will be moving back here in the boat, and he will be coming out of this boat, and two of these will be sitting here. Okay, and after that what will happen, they will go here, and these two will come out here, and this one will be coming here, and then he'll come here and take one of his friend. He will come back, and he will drop one of his friend, and his last friend is present here, so he will pick up him also, and he will come here. Okay, so this is how the solution for cannibals and the missionaries problem is. Okay, so at any point of time, if you observe, rewind the video and watch, there was no like in the same side of the river, there was no situation where there were less missionaries and more cannibals. Okay, that's what the solution of find. Just keep in mind that rule, it will be very simple for you. Okay, so let's see the theory part as well. How do you have to write in the exam? So first, basically you have to define the problem. What is the problem here, and the rules which are defined. They want to cross the river, but only two people can sit in a boat, and there should be no more cannibals than the missionaries at any point of time. So what is the state space? There are many. There are five tuples. B is the boat. C and M is one part of the river. How many cannibals and missionaries are there? C1 M1 is the next part of the river. How many cannibals and missionaries are there? Okay, so Basically those things are given, the different states are given. I'll explain one state. C and M is given. If C has -2 here, obviously in C1 it will be +2, because two people came from left to right side of the river. Same goes for the rest ones as well. And RL is where is the boat present at particular position. So solution is also given here, how many C's and M were there. And initially if the boat position goes here, if C goes 2 here, obviously 2 plus should happen here. And same things moves on until 3 and 3 stays here and 0 0 stays here. Okay, so this is one of the another solution which I just explained. Any solution you can use. Okay, so basically that's all for this video, and we'll continue this in the part 3. And make sure hit the like button, subscribe to my channel, and I'll see you in the next one.